at how to write equations for graphs of rational functions. Before we were graphing the rational functions, and you'll find that this is actually a lot easier once you kind of understand it. So the first thing that we're going to go over is looking at the behavior at the vertical asymptote. And so what this just basically says is that if a function contains a factor x minus h to the p in the denominator, the behavior near the asymptote is determined by the power of the factor. So this is saying if you look at the bottom of the fraction and there's an exponent, it's going to determine what's going on. So typically what we've seen is when it's got an exponent of 1. So exponent of 1 means that basically when you look at it, there's no exponent. So I would make a note there so you know that. Like when they're, I can't because this is a Google Doc, but you can. So what I'm going to do is I'm going to look at the asymptote, which is that red dotted line. And notice when we look at it that the arrows point in opposite directions. If the arrows point in opposite directions, ooh, I can. Look at me being smart. All right, if arrows point, oh, I can't, never mind. Dang it. Maybe I can. Oops. Sorry, I'm all zoomed in. I want to, actually, you know what, maybe I just want the text in front. There we go, that's what I want. Just kidding. All right, sorry. So if arrows point in opposite direction, oh my gosh, the struggle is real. That's why we're doing canning. No exponent. So when you look at this one, like that in red, I am talking, thank you. Especially when you look at this one. Notice how along the asymptote, this dotted line, the arrows are going in opposite directions. They're veering off, making an X shape. That means that the function at the bottom is going to have no exponent. It's going to make more sense when I do the example, I promise. This one, the next one that we're going to look at, if I can get this to work, when it has an exponent too, if they start to collide together. So the phrase we used in class was if they come together as an exponent of 2. And you can see that on this one especially. Oh my gosh. Delete that part. You see how they start along that dotted line? They start to come together like they're going to, Natalie said it in class today. It's like they're being shot up into the sky by the beam, and this is the end. That is what is happening. Or even looking at this one right here, they're falling into a hole. If it looks like that at the asymptote, then that means that asymptote, x equals, like if this was 2, x equals 2, then it would be squared. Okay, so kind of weird, but keep it in mind. We're going to go through some steps on how we write equations because it's very similar to what we did when we were writing equations for quadratics and equations for polynomials. So the first thing that you need to do in this case is identify the vertical asymptotes, because remember the bottom of the fraction is made up of the vertical asymptotes. If you factor it, it's just the vertical asymptotes. So we're going to write it in factored form in the denominator, so the bottom of the fraction, and then you're going to look at the vertical asymptotes of the graph and match it to one of these drawings. Okay, and if it matches this one, for example, then that means that your factor has no exponent. If it matches one of these guys, it's going to have an exponent of 2. Then we move to the top of the fraction by identifying the horizontal intercepts, because remember when you set the top equal to 0, you get the horizontal intercepts. And so basically you're going to look at the graph and see where it crosses the x-axis. And then once you figure that out, you're going to write it in factored form in the numerator. So the last thing that we need to do is solve for a. So a is the number in front of our fraction, of our basically a rational function. So this right here is the vertical asymptotes at the bottom, horizontal intercepts up top. I need to find a. So what is it stretching by, or what? So how I do that is I find a clear point, and then you plug it in. So plug in y, plug in x, solve for a. We've done that before. And then finally, you're going to write your final equation. So those are the steps. Now that we've got the steps established, we're going to go ahead and jump into our example. So we're going to look at this graph right here, and we are going to write our equation. So remember, step 1 was to identify the vertical asymptotes. I'm going to match the color purple. So my vertical asymptotes here are x equals -1 and x equals 2. So again, that red dotted line is at x equals -1 and x equals 2. So since I know that now, in factored form, that is x plus 1 and x minus 2. That is what it looks like in factored form. So then now what I'm going to do is I'm just going to go ahead and start looking to see what is the behavior, what is going on right there. Sorry, pulling this over here because I want to start writing my equation. Just because remember we have to put it in the numerator and the denominator. So I'm going to go ahead and change it to, let's change it to pink. Why not? Yellow. Let's insert an equation. So far our equation is f of x equals a. Oh, that's right. This thing's stupid. I guess I could just zoom out. And then in the bottom right now, so far we're going to have x plus 1, x minus 2. So I need to figure out if any of these guys have exponents. So that's where I'm looking at this asymptote. So zooming in on x plus 1, or x equals -1 at that asymptote, notice that the arrows, I'm basically just covering up my hand, you can't see that. But if I ignore this half of the graph right here, left of the, right of the x-axis or y-axis, I just have this section right here. And in this section right here, it matches this picture. Actually, it matches this picture. But notice that here, since it matches this picture, that means it's going to have no exponent. So on this factor right here, x plus 1, it's just that. It's not going to have any exponent. So now I move to the next asymptote, which is this guy right here. And this is where it's falling into the hole. Remember, they're coming together. So since they're coming together right here, and it matches this picture right here, that means it's going to have an exponent of 2. So x minus 2, I'm just going to put squared. All I do. So now I'm going to try to figure out, move on to step 2, identify my horizontal intercepts. In blue. So my horizontal intercepts are where it crosses the x-axis. I zoomed in way much. All right, so where did it cross the x-axis? Well, it crosses the x-axis at x equals 2. It crosses again, sorry, it was -2, at x equals 3. This right here is not the x-axis. This is the y-axis. So it actually doesn't cross the x-axis there. So the only horizontal intercepts I have are x equals -2 and x equals +3. So again, I have to put that into factored form, which is going to be x plus 2 and x minus 3. So then going to my function here, oh dang it, that's not what I wanted to do. Move it back up because every time I do something, I break it. There we go. I'm going to fill that in. So I'm going to put x plus 2 in the numerator and x minus 3. Right now, I'm not going to care about multiplicity. And the reason why is because notice how it goes straight through. That means it has multiplicity 1. So if it made a U shape, it would have multiplicity 2. If it made the wiggly shape, it'd be multiplicity 3. But that's not happening here, so I only got multiplicity 1. So I got x plus 2 and x minus 3. So I'm making some progress. So my last step, or my second to last step, is to identify a clear point and plug in to solve for A. So the clear point I have here is the y-intercept, which is the point 0, -2. So clear point. Zero, -2. And I'm going to plug that into the equation. So if I do that, then this equation is really quickly, I'm going to see if I can copy. I think I do. Can. That's one of the cool things. Yeah, let's go. All right. So when I plug it in, I'm going to have -2 equals 0 plus 2, 0 minus 3, 0 minus 2 squared, and 0 plus 1. So I replaced f of x with -2 and x with 0. And then I can start solving. Oops, is that going to work? Are you going to do? Yeah. All right. Actually, you know what? Let's Command Z that. So now if I keep solving, then I end up with 2 times -3, which is -6. And I end up with +4 times 1, which is +4. So -2 equals a times -6/4. So to get rid of this fraction, I have to multiply by the reciprocal, which means that now I'm going to have -4. Oh, yeah, that's right. Computer's dumb. Sorry, -4/6 times 2 equals a, which means that a is going to equal -4 times 2 is -8. Divided by 6, that reduces to -4/3. Actually, it becomes a positive because I multiply negative by negative. Thank you. I know you didn't say anything, but I'm pretending like you did. Stupid fraction. So then 4/3, really going to be that way, is equal to a. How can I make this better? Oh boy, did that fix it? Yes, it did. All right, so then last step is I got to write my final equation. Why isn't there no room? We're going to fit our final equation over here, just because I'm running out of room. And I don't want to, actually, no, we're going to run this guy up here. There we go. No. All right, now we're going to put it. So the final equation, f of x equals, and then I'm just putting the a in the right spot. Thank you for being patient with me. I know it's not fun listening to me. All right. F of x. Why is it still pink? I want it to be red. There we go. F of x equals. Oh my lord. 4. And then I can actually put the 3 in the denominator. And then I just put the rest of the stuff that I had. So I'm going to put that in the denominator, the x plus 1. And then the x minus 2 squared. So it's exactly like what we did when we were finding vertex form. Really? Let me do this. There we go. And then at the numerator, x plus 2, x minus 3. And this guy is actually our answer. So see, it's actually not that much work. Not that bad. So if you have questions, please let me know. I'll pause it there so you can actually see it and write it down. And then if you don't have any questions, you're fine. So good luck. Let me know again if you have any questions.